so you can see my keystrokes. Play click sound, turn that off. That ended up in the first recording and it was driving me crazy. All right. And now I just need to load my notes over here. Docs. And of course I'm not logged in. Great. Where do I log in? Annoying. Someone let her in. And while you're over there, will you fix the lighting? Thank you. We'll give us some light.
Yeah.
Why can't I log in on this? What do I have to do? All right, hold on. Okay, I think that worked. Where the heck is it? Okay, here it is. Yay, finally. Sorry about that. What? What now? Okay, great. So we are going to make some SOPs. So we made a new network, make a new file, new project, delete anything in it so we can start from scratch. And we're going to create a top and a torus top, not a top, a SOP, surface operator, torus. Torus is probably one of your more common surface operators. It's the one they give you by default when you create a geometry component because it's easy to recognize, right? Sometimes a sphere is hard to recognize because it looks like a circle, or it looks like just a flat dot if you don't light it correctly. Torus is pretty easy to recognize that you're looking at a torus because at every angle you can tell what it is, even when you're looking edge on, right? So torus, right? If you want to, so by default, I believe it shows you this torus in a head-on view like that. If you want to see the torus in a different view, you can make your viewer active. Where is my mouse? I want to turn my mouse on. Right, so you can make your viewer active, and then you can left click and drag around and see it in different ways. You can right click and move the camera up and down, but it's really easy to get it off the screen. If you get it off the screen and you're like, crap, where did it go? You can always hit the H key to home it, and it will go back on the screen, right? That's the same thing across Touch Designer. If you get lost and you don't know where you are, hit the H key to home everything. It will move the camera or move the network editor back to where all your objects are. Okay? Let me show you. There are some different display options. So by default, it shows you a flat shaded, this flat shaded primitive. With a Phong, actually it's not flat shaded, it has a Phong shiny material on it, right? But you don't have to look at it that way. One common way to look at it is with a wireframe. And if you have the viewer active, you can hit W and it will show you a wireframe, right? Also in this, if you right-click the screen, there is a sub-menu called Display Options that you can hit. And this will give you this Display Options sub-menu. And here there's different things you can see. You can click on points and it will show you points. It'll highlight those points. If you need to like reference a specific point and you need that point number, you can turn on point numbers and it'll tell you what point number you're looking at. Yeah, that's a little crazy. There's a lot of points there, so I'm going to turn that back off. There's some other things like normals, which show you which direction the point is facing. This has a lot to do with lighting, but you can use it for other stuff as well. Point texture coordinates, we aren't using those right now, so there's nothing to show. So I'm just going to turn this off for now, but I'm going to leave it in wireframe for now. How did you get the display? So with the viewer active, right-click on the object and open up display options. Okay. All right. Add a sphere SOP. Sphere. There it is. Okay, I think we've looked at this before. Go ahead and make that active as well and change it to wireframe, right? That way you can tell which way you're facing in the camera view. I think we've looked at this before, but you can change the type of primitive that you're working with on either of these from mesh to something like polygon. Especially in a sphere, I find the polygon type to be useful because it gives you this kind of geodesic buckyball arrangement, which is a little bit, it's symmetrical in both latitude and longitude around the sphere, whereas the mesh is more like the way a map is, a quadrilateral map, right? The other thing you can do here is, especially when you're setting on mesh, oh, let me show you. There's another one also, like NURBS. NURBS is a highly detailed type of polygon and can create some really high quality surfaces, but it's very computationally expensive. So if you're doing anything with animation, you should probably avoid using NURBS. And you should also try to simplify your polygons as much as possible, because the fewer number of points that you need to move around, the better. Especially because, like I said before, surface operators are all calculated on the CPU, not on the GPU. So change this back to polygon, mesh. And you can change the number of rows and columns to something less. And you can see how that is displayed. And so then it really, as I make this less and less detailed, you'll get it, it'll be shaped more and more like a disco ball, you know, with flat mirrored faces, right? So it depends on what you're doing as to how much detail you need. But the less detail you have, the better. Okay? Let's see here. We are going to go ahead and let's merge these. The merge is a really common surface operator. It allows you to, whoops, I'm doing it wrong. Let me go out of viewer active, and I'm going to right click on one of these outputs. That way it creates an inline object, and I'm going to choose merge. Yes. You should download. You should download the non-commercial version. Shouldn't need to, but will you help her?
Yeah.
Thank you. All right. So merge. It goes ahead and renders it back to the default way, and that's fine for now. Let's go ahead and add the sphere into this merge as well. And you can see that now it adds those into this and creates a single surface operator, which is a composite of both of the upstream surface operators. You can, here under torus, let's go ahead and change these parameters. I want to create like a Saturn looking thing, and I want the ring to not be intersecting with the sphere. So I'm going to change the radius of this ring, and I'm going to use the value ladder to do it and pull it out like that. Remember how you do the value ladder? You click and hold, and it brings up the value ladder, and then you can drag to the side. Go ahead and set the other radius, which is the inner radius, to something like that to create kind of a ring with some space between the sphere, right? So these are now merged into a single object with this merge. And if we wanted to like transform that by adding, right click on the output and choose transform. And if I want to see better, I can always make my viewer active and drag this around to see it at a different angle. And I can change the scale, or I can move this thing, translate it. I want to actually scale it. So I could scale this like to make on the y-axis to make it flatter. But you can see that it's scaled both the sphere and the ring because they are locked together with this merge. And in fact, we want to make this ring flat and leave the sphere spherical. So we want to actually put a transform upstream before this merge. So let's do that. So you can right click on the output of the sphere, or you can right click on the line and say insert operator. Either way will automatically insert an operator. And we're going to put transform here instead of there. And this way, oh wait, I'm sorry. We don't want it on the sphere. We want the sphere to stay the same. We want it on the ring. So add a transform. Okay, and on this transform, change the Y scale to like 0.1. I didn't want it completely flat. I wanted it to have some small amount of depth because it makes the lighting better. If you make it completely flat, the light will sometimes look kind of weird on it. So maybe 0.2. Yeah, I like that better. Okay, and now this transform, actually let's just get rid of this transform. And you can make this merge the viewer active, and you can move this thing around and see, yeah, it looks like Saturn. And I can change the torus's properties again to make that ring look the way I want. So I think I actually want to make the inner radius a little bit less. Something like that. Okay. Cool. So we have a Saturn now. I want to show you guys something here. We're going to animate this. We're going to animate this sphere with some noise. Yeah, let's do that. So you can right-click on the output here and choose noise. And this is kind of what we did in the homework. A lot of you did in the homework, and what we did with that blobby ghost, where you add noise to the points, right? So by default, this noise will be added to the point position. See that here under in this attribute, point position. I can change that to, there are other things like point normals, which will, now the thing is still spherical, but the lighting is being calculated by this noise, which makes it look kind of warpy, but not really, right? You can change this to diffuse color, which creates a color noise for the per pixel color, or per point color there. That's a common one to use. You could do alpha if you wanted things to be slightly transparent in different places. Like if I made this point and I started actually rendering it with a render, this would be places where it was dark would be transparent. So it would be kind of a ghostly in and out kind of effect, right? Let's go back and put it back to point position. I want you to notice something about this sphere going through the noise. So it's actually not being, the lighting on it is not being calculated correctly. If you look at the hotspot, even though this noise has some depth to it, and I'm going to change my primitive type here from, I'm just going to make it, I'm going to make it more, I'm going to add some more rows. I'm going to make this 20 by 40 or so. See how that makes the blob way smoother? And we're still at 60 frames a second right now, but I'm going to show you how that can drop really quickly. All right, so right now you can see that this hotspot is kind of in the same place. It's not moving around a lot, and that's because the normals are still just calculated at the sphere, and they're not recalculated with the noise. But you can fix that by putting in an attribute create object, or attribute create SOP. And the whole purpose of the attribute create is either to compute normals or to compute tangents. I don't know exactly what tangents are for yet. I'm sure we'll come to that. But compute normals is what really affects the lighting. And now you can see that that hotspot moves with the blobs, and the blobs gain a lot more volume than they would have before, right? It looks way more liquidy and blobby now.
What just happened with the compute normals?
We'll turn it off and look.
Well, yeah, I know, but what is it doing in the system? It's changing.
So the lighting, the specularity of the material that's being applied to this is computed by the normals. And the normals, if I go to here and I go into make my viewer active on this sphere, and I go into display options again, and I say show me the normals, those are the normals. Those are the direction that the normals are going. And that has to do with how the hotspot is calculated, right? Because when the normals are facing the camera, the normals underneath that point are facing the camera. That's going to be where the hotspot is. If I didn't compute normals here, and I went in here and I wanted to see, I go into my display options and I say show me the normals, you can see those normals are still pointing the same direction. We're changing their location, but we're not changing their direction. If I compute normals now, and now look at the normals, now their direction is being influenced by the noise, the positional noise, right? Which makes for a way nicer looking object. It's kind of cool with the fuzz. I didn't do this in my prep. Turn on these normals. That's kind of cool. All right, a hairy blob. All right, I'm going to turn that off for now. Okay, so now we have like a blobby Saturn. That's fine. I don't care if it's a blobby. I actually kind of like it. Let's show how we can animate something in this with LFOs. So let's see here. We are going to, what are we going to do? We are going to change the rotation and stuff of this torus. Is it there? No, you have to do it in a transform. So we have our transform here. And right now we're using the scaling function on this transform to make the ring kind of flat, right? Ring's flat. I can also rotate the ring here. I can say, okay, I want it to rotate along the x-axis, meaning if I rotate along the x-axis, then things will go this way, right? Because this is the x-axis. And if I rotate along the y-axis, it goes this way because the axis is running in the y direction. And if I rotate along the z-axis, it rotates like a clock, clockwise or counterclockwise, right? So let's rotate it along the x-axis. We're going to make this ring kind of dip downward, right? Maybe 50 is too much. I like 30 degrees, I think. Right? And we can animate this instead of just having it set at a particular rotation. I can take an LFO chop. LFO is one of the most common chops you're going to use for making an animation. And the one thing to really remember about the LFO chop is that there's different types of ramps here. By default, it creates a sine that goes from -1 to +1 and back down to -1. You can change this to a Gaussian, which just goes the same sort of easing in and easing out of a sine wave, but it only goes from 0 to 1. That one is very common. So sine and Gaussian are probably the two most common patterns that you'll use. The other one that you will probably use is ramp. And that goes from 0 to 1 and back to 0 and then to 1, right? So you can use all of these types to do different types of animations. Let's go ahead and change it back to sine. And we are going to apply this to that X rotation here. But we need this to go from like -30 to +30 instead of from -1 to +1. So I could there's a couple ways you could do that. I could, here under amplitude, I could change this to 30. And that will create a number now that slides from -30 to +30. But you'll often either want to drive multiple different things with the same LFO or have different ranges for different objects, which I guess is kind of the same thing. So I like to leave this at 1. So it's creating a number that I completely understand, which is, whoops, not 0, 1, not 10, 1. There we go. Which is going from negative. Now it's like messed up the zoom level on this thing. R. With it active, R. There we go. Thank you. What's that short for, Dean? Oh, range? Reset. Cool. This is a value that I completely understand and can predict in my head how it's going to function. If I change this to 30, for example, then the frequency really comes into play as far as like the speed of the thing. And the frequency is way more sensitive than if I change the frequency on a value going from 0 to 1. So that's one of the reasons I like to just stick with 0 and 1 unless there's a real good reason not to. And then what you do is you have a downstream transform. No, sorry, math. The most mysteriously named one because, yeah, you do math, but I mostly do ranging with it. So here I set what my input range is and what my output range is. So this is creating a number. Because we left it alone, I know it goes from -1 to +1. And now I can change the output range into anything I want. So I'm going to have that go from -30 to +30. And then what should I do to export this to the rotational value on this transform? Chop 2? Well, you don't need to because you can export it directly. What was that?
Like, when do you know what you have to use that or not? Like the chop 2, for instance?
Chop 2. Well, what does that create again? Chop 2 goes to a, oh, that is, chop 2 is in a different family, meaning you go from chop to whatever you want in that family. So if you're using a chop to create a texture or to create points, then I could use a chop to sop, or I could use a chop to top to create a texture, or I could use a chop to dat to create a data table, right? So it depends on what family of objects you're looking for the data. A lot of times, though, the data can be interchangeable in whatever family. So it's programming style, and it's also like if I need to have a whole bunch of different things, which we might get to depending on how fast we move today, that I want to affect these objects that we're gonna later today, we're gonna do, if we get to it, we're gonna do what's called instancing, where instead of having 10 different objects independently mapped, I have a single object and I tell it to be rendered in 10 different places and have 10 different settings before it's rendered. To do all that stuff, if I had a whole bunch of different parameters that I needed to affect on each one of those, then I may want to send it to a DAT table, because then I can see all those values. I can do a lot of list processing with them to get them in the order and the way that I need. And you would then use a chop to dat in that case, right? In this case, all we need to drive is one parameter of a different object. So really, we could just export directly from the chop to the parameter that we want to animate. But before we do that, what should we do? There's one kind of best practices that isn't technically necessary, but it's something you really want to do.
No.
Exactly. No, gold star. So you always want to do, and it's not technically necessary, but you always want to go to a null before you export. And the reason why, anybody know? Yeah, so I can edit upstream, I can add, I can rearrange, I can add another math thing here, I can merge it with 3 other different chops or something before, and then I don't have to worry about redoing all my exports. So we're going to take this null and we're going to map it to or export it rather to the rotate here command. So to do that, the easiest way is to hit the plus button here to expose the individual parameters, and now go ahead and put this make viewer active on the null and drag it over to the parameter that you want to send it to. And then I can either say export chop, which will make it as an export, or if I'm going to do additional expressions, like I want to take that and multiply it by 0.5 or something, instead of doing an export chop, I could instead do relative chop reference, which gives you the same value, but now it's in a Python expression that I can say, yeah, take this and multiply it by 0.5, right? But I don't want to actually point it by 0.5. Okay, so yeah, why isn't that going very high? Thought it would go.
You want to go on to 30 degrees?
Yeah, but I thought I'm going to positive 30 degrees too, and it doesn't look like, I'm always seeing the top. I'm never seeing the bottom of it. Why?
Oh, because your camera's moved. If you
Oh,
have-
because this
if you
is the
have
camera.
a null at the end of the chain.
There we go. It's just the view, because we are actually not even rendering this thing yet. We're only looking at it in these viewers, right? Let's go ahead and actually render this thing appropriately and put cameras in. So do you remember the objects you need to render and actually have things output to your performance mode?
Light, camera,
Action.
yeah.
No, lights, camera, and what's the other thing? What? No, you need a geometry. Geometry, lights, and camera. So let's go ahead and make that, and then you'll need a render object. But make the geometry, light, and camera first. Those are components. So geometry. Hey, look at that. They gave us another torus. All right, and we need a light or a camera, and we need a light. And now we need a top, render top. And then it automatically hooks it up for us. Okay, so here we go. Now, what I want is for this, instead of rendering this silly default torus, I want it to render my blobby Saturn over here. What do I do? Nobody? So what is being rendered? Geometry. What's inside geometry? Dive inside it. There's the torus, right? So I could, if I wanted to, I could delete this torus, go out, grab all of this stuff, and paste it back into geometry, and then set my render and display flags. But why? I mean, it's just going to make it a little bit harder to get to, and I'm going to be doing all this stuff with LFOs, and I like it outside of that component. It's totally fine to do it if you want, but you can also, instead of putting these objects in here, you can send this into this by using a select SOP. So make a select SOP, and then it says, hey, what SOP do you want? And we have to remember what this is called, and actually what should we do before we export? Yeah, we should add a null SOP to this merge. So go ahead and select, click on the merge, and then box select everything else. I'm just giving myself some room, so actually you don't necessarily need to do this if you have plenty of room. And then I need to create, whoops, instead of doing it that way, I want to right click on my output and select null. And I can start to type things to make me have fewer choices. Okay, and so this is null 2, and actually I'm going to call this, I'm going to rename this, and I'm going to call it final SOP. Okay, that way I can easily reference it. And I'm using camel caps, where I start with the first word not capitalized, and then the second word starts with a capital. That's just, you can name it however you want. You can use whatever naming conventions you want. That's a common one in programming, and if you stay consistent, then you won't have to remember how you capitalized things. Okay, and so now in this geometry, dive back into it, and on this SOP, I could try and say, what was it called, final SOP? But it's not going to work, because it says, wait a second, there's no path. The path is bad. There's nothing called final SOP, because it's looking in project 1/geo1. It's not looking in project 1/nothing, right? It's looking inside of itself. It's not looking outside of itself. So do you guys remember what the how to tell it to look outside of the object you're currently in. It's like an old MS-DOS trick. Used to be the same way to get out of the current directory you're in and go back to the previous directory. And it's ... / and then final stop. Right? ... this is called a relative reference, and that means go back one level. I could use an absolute reference, and I could say / project 1 / final stop, and that would work as well. But I'm going to leave it as ... Whoops, not single dot, 2 dots. There we go. Okay. And so now we are rendering. Oops, we are not rendering. What happened? What did I not do? Why am I not rendering? Anybody know?
Click the render flag.
You got to click the render flag. So now I click the render flag, and now I'm rendering, but I don't see it here in the geometry 1. So what else? There's another flag called display flag. You have to hit both of them if you want it to operate the way you'd expect, which is you don't have to actually display it. It doesn't matter, because as long as you're rendering it, you're happy. But usually you want to set both the render flag and the display flag. Okay, so now here, this is what we're rendering. And if I want to go into perform mode, what happens? Oh my God, black screen. Why? Out. That's right. Nothing is going out of this project. So if you scroll back and you just keep scrolling back, you'll get to the root directory. And the perform mode here is looking for an output from project 1. And currently you can see there's no output from this comp. Right? There's no line on the side. So that's telling you, that's the reason why. But you guys know you just need an output. So if you create an output top, or just out rather, top, and you patch that to your render, then when you go into perform mode, you get your output. Okay? Questions on this so far? All right. So what to do? First thing to do, make this view a little bit better. How do you do that? First thing, we're too close to the object. What should I do? Translate the camera out. What a great idea. So look, this is the position. If I click on camera and I'm in this component, it'll move every single thing that's inside of this. There's only the one camera inside here, and that's fine. That's all we want. And you can see by default they set it at 5 units back from the origin on the Z scale. Let's go ahead and make that more like 15. And now we're a lot further away from our blobby Saturn. Right? And I wanted to do something else on this blobby Saturn to make it more interesting. First of all, this LFO is too fast. So I'm going to change the frequency down to something like that. And now I want to actually add another one here. I'm going to make another LFO chop. And this one, I'm going to change the type from sine to ramp. And what am I going to do? Okay. And go ahead and patch in another math chop. And go to range. And this is going from 0 to 1, so we don't need to change that. But we do want to change this to range, and we're going to have it go from 0 to 360 degrees. And so now we have this counting up by degrees. And we can, on this transform, I'm going to send that to the rotate Y But before I do that, what should I do with this chop? No, that's right.
What was the output?
Hmm?
What
Here.
map the range to?
360 degrees. Yeah. And then send that to the Y rotation here on this transform. So I can make my viewer active on the null, and make sure that you have on your rotate that you have this expanded out, and drag it over to the RY and say export chop or export reference. I'm just going to be consistent and say export reference. And so now it rotates around here like a wobbly ring that's rotating on the ground. It kind of makes an interesting, adds some character to our blobby Saturn. Okay, any questions on this? Cool. So, yeah, we could color this if we wanted to. We could make it look cool in different ways. We've done some interesting animations already. One other thing you can do is scroll out, and is it here? I think it is. Look, yeah. You can actually have a background color. If you don't want it to be rendered in black, you can set a background color. So set something interesting. Like I'm going to do a midnight blue for now, and I set the background color, and it's still black. Even when I go into perform mode, it's still black. The reason why is because there's a background alpha here. So if I turn this up, I can set any amount of alpha from 0 to full opaque alpha, right? So this doesn't put blue over the object because the object being rendered, the blobby Saturn here, you can see there's alpha. That alpha is expressed by this checkerboard pattern, right? So background will be blue and will show anywhere where there's a checkerboard. Okay? So that's how you can set a background color. All right. So, I did want to show you something. So right now, we are still at 60 FPS. We're cooking with heat. We're doing well. What happens if instead of this sphere, I load something with a heck of a lot more vertices? And in fact, just to simulate that, I'm going to leave it as the sphere, but I'm going to go here and change my rows and columns from 20 rows and 40 columns to 200 rows and 400 columns. Yeah, now look at my FPS. 12, right? And that's because all of these, we're adding all of this noise to how many different vertices? To 80,000 vertices. We're having to calculate noise on 80,000 different vertices. And there's no way we can do it in the time we have for each frame. So our frame rate has took a nosedive, right? So in this case, that has meant nothing to the final output. This is smoother, but the likelihood at 1280 or at 1280 by 800 that anybody's going to tell that is not very good, not very likely. If you're outputting to a file and you want to make sure you're rendering really smoothly and you don't care how long it takes to build a single frame, you can change your real-time. You can set your real-time flag to something to off, and then it will build it one frame at a time, even if it has to go slower to do it. And that's cool for outputting to a file, but not cool for doing real-time stuff. So really, it doesn't need to be this complex. And I would caution you guys, whenever you're using models, 3D models, that you use one with a low amount of polygons. The lower amount of polygons you can get away with, the better. How many is too few? That's up to you, and it's really up to the shape that you're trying to use, right? If you decide that that's way too, it looks way too crappy, then you can try a bigger polygon. But go ahead and set this back to 200 by 20 by 40 to get us back to our 60 frame rate. Okay, so what do you think would happen if I took all of this and I wanted 64 of these blobby Saturns put on the screen? Do you think I'd still be able to do it it's still recovering right now. It's not quite up to 60 frames. It's almost there. But do you think I could still do that in 50 frames, 55 frames a second? No. In fact, you'll start, when you add like your 10th object, even primitives, you'll start to notice frame rate issues because it's having to calculate all of those on the CPU, right? Every time you use a SOP or any SOP, whether that be a model file or a primitive, all of those vertices are calculated on the CPU. So if I wanted to, instead of, if I just wanted 64 Saturns, and I don't mind that they're all the same, then and there's some tricks that even if they are the same, you can still make them look different in various ways. You can use something called instancing to render these things in multiple different places in one frame. So the way it works is, what the render is doing is it moves all these objects that are in the scene, and when they're in their final position for the scene, it draws the frame and sends that out. If you use instancing, before it draws the frame, it moves it again. So it draws you have it in one place, it's rendered in that place, and instead of then erasing that frame and drawing the next frame, it moves it to another place, renders, moves it to another place, renders, moves it to another place, renders, and all of this is done on the GPU, not the CPU. And then it creates the frame after you've moved it to every single place that you specified. And so I can easily specify 64 different places to put this thing, particularly if I use a 3D object to generate those positions. What are you talking about, Jackson? This is crazy. Well, this will make more sense when we do it. All right, so first thing we're going to do, we're going to generate the positions to put this thing in. And we're going to do that by using another SOP. So go to SOP and choose box, which is one of your very basic SOPs. Did I skip a whole section? Yeah, I did. Oh well. I think I should just skip this section and come back. All right. So yeah. This is a box, and it's just if I go in here and I turn on wireframe, it's just 6 points right now. Especially if I go into here and I say display options, show me the points. And there's the 6 points. Okay. Let's see here. We did that. We did that. We did that. Okay, here we go. Sorry, I lost my place. All right. What I want is I want a lot more than 6 positions. So what I can do is change the scale of this from 1 by 1 to 1 by 1 to 1. Change it to 3 by 3 by 3. That still is only giving me 6 points, but it puts those 6 points 3 times further away from each other. And I can now click on this checkbox next to the grayed out divisions. and change it from 3 divisions. For now, let's make it 2 divisions, 2 by 2 by 2. And now you can see it's giving me how many different points? 27 points. Not sure why it's 27 and not 26. Oh, because of the shared point in the very middle is shared by four different cubes. And that's the only one. Okay, so I have 27 different points. Let's send this to a null. Okay, and yeah, and call this null. Let's name this null, and we're going to name it instance, I believe. No, I'm wrong. Just leave it as whatever it's called. Sorry. You delete it if you want, and just make another one. Okay. Now I can, here under geometry, I can go to the tab called instance. And first thing I do is I turn on instancing, and it disappears. And the reason why it disappears is currently we haven't told it where to put anything, so it doesn't put anything anywhere. When you turn on instancing, it's waiting for its instructions about where to put things. And so then it says what instance, chops, dat, or sop. It can use any of those types. Do you want to reference? For now, let's go ahead and just reference this null3, which I can do either by typing null3, or I can go over here and drag it onto the thing. Okay? And now, why don't I see anything? Or why do I only see one? Maybe they are all too close together. Oh, I know why. So I don't see anything. And the reason why is I haven't assigned those positions to any variables or any parameters yet. The parameters we want to assign it to are, in this case, we want it to be in multiple different positions, right? That's called translation, right? So we need to assign it to this tx, ty, and tz. And what we need to do, what we need to know in order to do that is how those points are being labeled, which there's an easy drop-down list here. If you click on the triangle next to what you want to have assigned, it'll tell you what data is currently in that SOP in this case. And it's P0, P1, P2, which has to do with the X, Y, and Z of the point, and N0, N1, and N2. What do you think those have to do with? Normal direction, right? We're not even going to really use the normals for now. And we probably won't get into normals until like the second half of the semester. But for now, we want to assign these TX to P0. And look at that. All of a sudden, we have 3 Saturns side by side. And I want to change the Y now to P1. And now I have 9 Saturns. And then I change the TZ to P2. And now I have even more. If I change my view here.
Hey, Jax.
Yeah.
When I put null3 into the instance chat, I get a little error flag. Says that the tab is bad.
Did you have it? How did you do that?
Typed it in. Oh, so maybe I should track it.
I mean, maybe you typed it wrong. If I type it, it works. If I put in something wrong, like null2, oh wait, that is something that exists, like null5, then it says bad path. So you probably typed it wrong somehow. If you try dragging it there, yeah, you won't have any problems. Okay, so let me change my camera's position now so I can maybe see these a little bit better. So I'm going to move the translate, I'm going to move it up with the translate Y. But when I move it up, the object moves out of frame. And so what I want to do is actually make the camera, force the camera to look at the objects, no matter where it is. It'll automatically rotate to look at it. And I can just do that by setting the look at here. And I can set that to be GO1. So go to camera and on look at, change this from nothing to GO1. And now it's always looking at that. And you can kind of see, it's a little hard to tell, but you can see that there are now not only the three rows and 3 columns, but there's a Z depth of three sets of those squares as well. And you have how many different shapes now? 9 or something, right? And let's see, 3, 6, 9, yeah, 9 different shapes. And I'm at 41 frames a second. I can tell you I'd be a lot less than that if I tried to render 4 shapes at the same, if I tried to do all of these 9 shapes independently. Yeah. I can also, so now to make this look better, what do I want to do? I want to, whoops, what did I just do? Okay. What do I want to do? I need to transform this. We're going to add a transform in between here. And I can say insert operator by clicking on the line. Or I can right click on the output of the upstream object. And I'm going to choose transform. Now I can scale these in the X, Y, and Z to make more space between the positions. So scale, I don't know, 3 by 3 by 3. And now I need to push my camera back further. So from 15, I'm going to make it more like 25 back. It's getting better. Maybe more like 35 back. There we go. That looks better. And I can move my camera up higher, like at 15, so I can kind of see these from the top. Okay, and what now? Oh, we can animate this, transform, and kind of make these objects collapse in on each other and explode outwards, which I think would be interesting. So let's create another LFO. And change the type on this from sine, because I don't want these to go into a negative, because then they'll just go slide past each other and move to the opposite side. I want them to collapse into 0 and then go out. So I want it to go from 0 to 1 instead of from -1 to 1. So change this to Gaussian. Okay, and then let's send that to another math to set the range, and then to a null. And here on the range, on the math object, I'm going to set this from 0 to, I don't know, 3 for now. And I want this to go a lot slower, so frequency 0.2. And now click on your transform here, and what I want to change actually is this uniform scale, because I can scale all of the values at the same time with the uniform scale. So I can expand that. I can put this into active, and sorry, wrong one, active. I want my LFO to be active, and I can send that to here, and I can either make this a chop reference or just export the chop. And now you can see they collapse down from a single Saturn into multiple Saturns. Looks like I still need to push my camera back even further, or I need to scale down the objects so they're not so big. I think I'll just push my camera back because that'll be quicker. So let's make this like 50. And go back into here. Yeah. Cool? All right. So now let's animate the camera a little bit to make this even more exciting. Where's our cameras? Right here, and we don't have any LFOs going into this yet. So let's make one. Make an LFO. And we're going to leave this one as a sign. And actually, we're going to call this, let's rename it and call this Cam X. Oh, that's not what I meant. You can leave that called Cam X, it doesn't really matter, or you can undo. What I actually want to do is rename the channel. And so click on the channel tab up here and change this as Cam X. And this is something that isn't really necessary, but I wanted to show you guys because when you are dealing with a whole bunch of chops, and especially if you're going to merge those chops into a single list, a lot of times it's helpful to have specific names, because you could have, see how this one's called, it's null1, but the value is called chan1. This is null2, but the value is called chan1. If I were to merge these two, that's two different channels that are supposed to be called chan1, and it's going to turn one of the chan1s into chan2. And now it's confusing about what chan1 is chan2, right? Whereas if I had set this to be Cam X, and now I make another one, copy and then paste, and call this Cam Y, and then make another one and call this Cam Z, and now merge these with a merge chop. I'm going to go ahead and attach it to one of these, right clicking, and go to a merge, merge. And now go ahead and hook up the other two. You can see that it creates a single chop with 3 channels called Cam X, Cam Y, and Cam Z. And now referencing those will be a lot easier. So go over to your camera, and what we want to do actually is we want to insert we want to insert another math object here. Let's do it the shortcut way, just so that I talked about this, but I didn't do it. So the shortcut way, especially if I don't want some particular offset scale that goes from, instead of going from -1 to +1, it goes from 25 to 45. That kind of thing, you'd probably want to use a math chop. But if you just want it to go, instead of going from -1 to +1, you want it to go to from -30 to +30. Instead of using a math chop, you can just change the amplitude to something bigger. So let's actually figure out what would be a good values to work with. So we're going to change the translate on the X scale here. So I'm going to do the value ladder and go over to the side for -40 or so. Yeah, -40, and then if I change it to +40, I can see the other side. So let's have it go between -40 and +40 on the Cam X. So all I have to do on this amplitude is change that to 40. Okay, and then for the cam Y, let's do like 30 degrees. So on the amplitude for this, make this 30. And make the frequency slower on both of these. And then on the LFO6, on the Cam Z, this one we definitely want to have kind of an offset range. So let's go ahead and insert a math chop here. And on the range, so this is going from -1 to +1. So change this from 0 to 1 to -1 to +1. And then change the output range from, what are we at now? We are at 50. So maybe we have it go between like 40 and 60 or something. So on the output range, change that to 40 and 60. Okay. And now send this to a null. Where's my null? NU, there it is. Okay, and we'll export to our camera translate things. So open up your camera preferences by highlighting parameters, rather, not preferences. By highlighting and making sure if you don't see anything over here, what's the key you do? You push to get it back? P, that's right. And then go ahead and expand your translate so you get the X, the Y, and the Z as 3 separate lines. And now over here, make your viewer active on this null. And then it matters which one you're highlighting on. That one will be the one that you export. Okay, so export X to TX. And I'm gonna do chop references. And Y to Y, chop reference. And Z to Z, chop reference. Now let's take a look at our output. And now our camera is moving back and forth at the same time as things are exploding and contracting. There's lots of stuff going on here. And when we're running in performance mode, we're definitely at 60 frames a second. When I'm out of performance mode, I'm at 60 frames a second. So we're doing really well. Okay. Any questions on this? Is this making sense to you guys? It's a little weird. I know with the whole like instancing, but just the thing to remember with instancing is that the positions of those objects are influenced by whatever you send into it. And right now we are sending this surface operator's positions through this null into it. Let's look at what else you can do though. You don't have to, it doesn't have to just be positions. It can also be color or rotation. So you can make all of these, instead of, see how they all rotate perfectly together, we can make them rotate differently. And we can make them all be different colors. Let's go ahead and switch over to our Valentine's Day themed patch by adding some hearts to this instead of the Saturn. So let's go ahead and download. I put on the website, I put a heart.obj. If you go to the website and go to week 3, you should see below the Gangnam Style is the heart2.obj. Go ahead and download that, put it someplace where you know where it is. And then from your Finder or your Explorer window, just drag it into the network editor. And now you have this heart. Okay, what should we do with this? We should put it up here and just change the reference from our final SOP. And now you have hearts. And our camera is still animated, but our other stuff is not. And actually, to save ourselves a bunch of overhead, let's go ahead and so save this file. Actually, put it back the way it was. Go ahead and hook this merge back up to the blobby Saturn. So now it's back to the way it was. And let's go ahead and save this file and call it class 3 or week 3. Actually, yeah, week 3 is fine, or even better would be week 3_1. Okay, now let's save as and name this week 3_2. And go ahead, now that we have that previous version saved under week 1. So we can go ahead and delete all this stuff that we're not going to use in this next version for the week 2, for the part 2. So go ahead and make sure when you box select, make sure that you regular select something that you want to delete first. If I was just to box select this, I would also delete this heart because it's currently selected. So I want to keep the final SOP, but I'm going to from this merge, I'm going to get rid of all of my channel operators that are driving that, and also all this torus and sphere stuff. So boom, it's gone. And now my final SOP is mad. So I have to hook up the new object to it. There we go. Okay. So now we don't have all that stuff going on. And so what we're going to do now is, what are we going to do? Instead of this SOP, this null SOP, driving the instancing, we're going to first export it to a DAT. And then we're going to add some other stuff to that DAT and then reference the DAT on the instancing here instead of this SOP. So create a SOP2 object. So you can right click on the output of the null3 and then go over here and click on DAT, and then it truncates the list to only options that are available to you, and SOP2 is the one that we want. Okay, and that creates this SOP2 DAT, and if I zoom in, and this brings up an interesting point. You might be tempted, especially when you're working with DATs, you're like, I need to see all this data and it's off the screen. You might be tempted to like resize it like this, and that's okay. But the best practices is to leave all your objects a default size, and if you want to see into this, zoom in on it. The reason why is that you'll end up with objects all different sizes and fonts all different sizes, and sometimes fonts can get too small to read. And if you leave everything the same size and you just zoom in on what you want to see, you'll be happy. You'll always be happy. Where otherwise you might create some problems for yourself. But really it's just a programming style. But you can always click on Viewer Active, and that will give you a scroll bar here that you can scroll over to the side or up and down to see more data. But look what's in here. Remember when we were mapping those, we had to map the P0, P1, and P2. Here are those listed as column headers in this SOP to DAT, right? Here is also the PW, which I'm not sure what the W stands for. I think that has to do with maybe alpha or something. And then there's also the normaling, the normal points. Yeah. So what we're going to do is we're going to add to this list some stuff about color information. And in order to do that, we actually want to merge it with another DAT. So we're going to create a merge coming out of this SOP2. Merge, there it is, merge. Okay, and right now it just copies it straight across because there's nothing else to merge it with. And we need to create a new DAT, and this is going to be for color information, and we want to drive this with noise as well. And there's a bunch of different ways we could do this, but one of the easiest ways is to actually use a top, a noise top. Okay, noise top. And all we need is, how many different points do we have here? 27 polygons, 27 points. We need 27 random numbers. Right now it's creating an array of, if you go to, on the noise, you go to common, this is the resolution. So it's creating 256 by 256 points, which is way more than we need. We only need 1 by 27, right? 27 points, yeah. 1 by 27. Okay, and now it creates this like strip with these different values here. On your noise, make sure that you have a 3D GPU type of noise. Simplex 3D is the default, and that's fine. If you use any of the other ones, then it's going to be on the CPU and will start to slow you down, although they're not that bad. And now go in here, and we need to animate this noise, and we're going to animate it by changing the Z translation, which will like make it's you can think of this noise as a single slice of a cloud. And if I fly this way into the cloud, I'll still have my single slice, but those slice values will be changing as I'm moving through the cloud of noise, right? So on the translate here, on TZ, I'm going to go ahead and go into expression mode, and I'm going to use abs time dot seconds. And now you can see it's animated this, and you get changing values that automatically change over time based on the absolute time that has occurred since we started this patch. And because the noise cloud is an infinite noise cloud, we can just keep flying in one direction and always get different values. Okay. Now we want colors, and currently this is only black and white. And there's an easy thing to change there. And if you go back to the noise tab up here and change it from turn off monochrome, it'll give you 3 channels of noise that correspond to a color. Okay, now starting to run out of time. I think we can get through at least this part before the end of the class. Let's export this to a null. Okay, and now we are going to go from this null to a chop2, or top to chop. So right click on the output, then if you click on chop, it'll truncate the list to only things that are available exporting from a top, and one of those is of course top2. And now we have values here, but these values are not the kind that we want. We actually want them go to crop, and right now the crop is set to row, and we have this vertical strip, so we're only getting 1, 2, 3, 4 different values here instead of 27, right? So on the row, change this to vertical column, And now we get 27 different data points on 3 different channels. But we really don't. Actually, look down here. If you look really carefully, this is showing you what points you're outputting. And this goes from 1 to 14. And why? Well, it's this default value that I personally think is stupid. I haven't figured out why it's this way. But it starts halfway through your data set at this v start 0.5. Go all the way back to 0. Now you have your full data set. I don't know why they have that way. Why would you only ever want half of your data set? Someone tell me if you figure it out. All right, so we can use these values now. We have, you can see it goes from 0 to 27. We can use these to drive the SOP2. We just need to add it to, no, we need one other thing. We need it to go from a top 2 to a chop to a DAT 2, right? Do I have that in my picture? Do I not have that in my picture? I guess I don't. Yeah, I believe we have to then go to a DAT on the output of this. So chop 2, DAT. Yeah. Now, currently this is just giving us numbers, and we want it to slot into this list that has header labels because we need it to reference those header labels. So we could either merge it with another one that has just header labels, which would be stupid because all we really need to do is here under chop2, click on this include names, and now it adds the header labels R, G, B, and A. And now pass those into the merge. So let me move this up, move this merge down, and pass this into the merge. All right, now let's make sure our values are there. And if I go into viewer active, I'm seeing the whole width, but I don't see my values. If I scroll down, they're actually way down. These are my values down here, R, G, B, and A. So it's not added them to the place that we want. It's put them underneath, and we actually want them to add columns instead of add rows. So go back, go out of active, and where it says how here, append rows, change that to append columns. Now we've made this master list that not only has our positional data, normal data that we don't need, but it also has these added R, G, B, and A data that we're going to use for the color. So go back to your instancing parameters on Geo1. Instance. There are 2 tabs of instance here, and you're like, what is it have 2 different instances? No, I think it just means that they didn't want the parameter window to get super long, so they just truncated and put it into 2 different directories. But there's just more stuff. So here is your translate, here is your rotate, your pivot stuff, and this is rotation vectors, up vectors, which I'm not sure what the up vector, I think that has to do with normaling, and more importantly, the color. And so we need to map the color down here. So again, you can use the arrows on the side and you can choose from it, but it doesn't seem to be populating that list. I think all we have to do is put R, G, B, and A over here. Did that work? No, that didn't. Why didn't that work? Replace, that's what we want, yeah. What did I do differently? Ah, thank you. So that's what we didn't do, is we're still exporting from this null 3, right? We don't need to anymore. We've merged that data into this master merge here. Let's actually send this to a null dat. And this now, we're going to rename this. Instead of null2, We're going to call this instance. And now it'll be really simple to here under Geo1 to, on our instance chop dat or sop, we are going to reference the instance dat. Instance. There we go. And now look at those beautiful colors that we have right in time. We didn't get to rotation yet. Let's take a look. So they're kind of merging together into like one multicolored heart, and then it explodes out into multiple different hearts. And actually, I'm gonna change my background here from blue. So if I scroll out and I change this go to hover on project here, and I change my color, background color. I'm gonna change it to pink, and now I have a pretty cool Valentine's Day thing, right? There's one other thing we didn't get to, and that was I was going to add independent rotational vectors to each of these with the same kind of noise thing, and you guys could probably figure that out if you tried. It would work almost identically to this parameter, to this paradigm that we did down here, where you have a noise going to a null, going to a a top to chop, going to a chop to dat, merging with the master list. And you don't have to add another merge. I could add another list and have 3 lines going into this, and it will just append on rows, on columns, and then sending to another null, and then referencing that correctly in your geo instancing. And actually, I thought it was Rx, Ry, and Rz. When I tried that, it didn't work correctly, and what did work correctly is actually this rotate to vector. So if you mapped this to whatever values you came up with, or whatever you called them, and you would probably want to do the same sort of thing where they'd have a name here and you included that name so that you can reference them, then you can make these rotate independently. And I'll just show you kind of what that looks like now. So go ahead and save this, and I'll just show you my version really quickly. And you can see kind of what is possible when you're working with multiple different parameters on an instancing level.
Is it possible to change the primitive shape that the box is using? Or is it already the box?
Yes. No, you can. So right now we're using a box. You could make that a sphere, and they would come out in a spherical arrangement. So yeah, go ahead and play around in your homework with trying different shapes and different parameters for that shapes. I just didn't have enough time to try out a bunch of different things. But you can see, yeah, so it's possible to get independent rotations on all of these and see how they are all kind of like flipping in different ways, and this at the same time as the camera is examining them in different ways. So there's a heck of a lot going on here, and it's running at 60 frames a second. And I changed my divisions, and so there are 64 points here instead of 28. Or 72 or something. It's 4x4 instead of 3x3. All right, so we're out of time for that for today, but let's take a look really quick about the homework. And I think we got through enough things that I won't have to adjust this homework. So create a touch network that deforms or moves 3D SOPs. Make sure normals are correctly calculated if you're doing blobby spheres or whatever. Animate at least 2 parameters with LFO chops. Animate at least 1 parameter with absolute time or absolute time.frame. Python expression. Use instancing to multiply the object and arrange it in an interesting way. And then make sure that your network will output in performance mode. And just I'll just add one thing, and that's do something other than what we did in class. Do something interesting beyond what we did in class. Okay, does that make sense? Does everybody think they can do that based on what we did today? Great. Well, have a wonderful Valentine's Day and a wonderful, what is it, President's Day, 3-day weekend.
Yeah. Yes.
So that's awesome, and we'll see you next week.
Question.
Yeah.
Do you know if there's somewhere in our school that you can borrow like a computer?
A Connect?
Yeah.
Yeah, I can loan you a Connect.
Oh, okay.
Yeah. You have a PC?
Well, I'm building one this weekend.
Okay.
And then I'm doing a thesis, which is like an interactive audiovisual and local space.
And you want to do it in touch?
Yeah.
Okay.
I wanted to do that portion in touch, so I haven't worked with it. I've seen it done before, and I've had like, I know some people have done it, and I just kind of wanted in the audiovisual.
It's ridiculously easy to touch.
Yeah, that's one of the great things about touch. It's so much easier,
Yes.
but it only works on PC because it
Yeah.
only uses the official SDKs.
Mhm.
So as long as you can either you have a PC or you can boot camp your Mac into PC.
No, I'm very excited to build this PC this week.
Yeah. So I have one. I believe I have two. I have two V2 sensors, but only one interface for them that'll allow you to connect it to your computer. And then I have a lot of V1 sensors. I have like 4 V1 sensors, and touch can interface with either or. Of course, the V2 is better
Yeah.
as far as giving you better data.
Mhm.
But at the same time, the V2 can have problems if your computer is running a low frame rate. It uses it uses pretty much every bit of the USB 3.0 bandwidth. And if your computer starts dropping frames, it's going to start slowing down and tracking as well, and you can lose tracking data. And the V1, if you can get away with a V1, it's a lot less bandwidth data, and you can have a lower frame rate and not have problems. So it's like, which one you want to do. But yeah, I have sensors I can check out for your project.
Okay, can I send you an email this weekend?
Sure.
And then,
Yeah. All right. Stop.